Introduction to liquid crystals, classification and properties. What is meant by liquid crystals? Simply we can say that it's a state between the solid and liquid. That is a state in between the solid and liquid. Now, there are three states of matters, that is solid, liquid and vapor. By increasing the temperature, the solid changes to liquid, and again by increasing the temperature, the liquid changes to vapor. Similarly, by decreasing the temperature or by cooling, the vapor changes to liquid, and by decreasing or cooling the liquid changes to solid. Okay. Now, in between the solid and liquid, there is one more state, that is liquid crystals. That state is called liquid crystals. ഇപ്പോൾ സോളിഡിനും ലിക്വിഡിനും ഇടയിലുള്ള ഒരു സ്റ്റേറ്റ് ആണ് ലിക്വിഡ് ക്രിസ്റ്റൽസ് എന്ന് പറഞ്ഞു. ബട്ട് all the solids does not exist as liquid crystals. അപ്പം എല്ലാ സോളിഡ്സും ഇങ്ങനെ ഒരു ലിക്വിഡ് ക്രിസ്റ്റൽ എന്ന് പറയുന്ന ഒരു സ്റ്റേറ്റിൽ എക്സിസ്റ്റ് ചെയ്യുന്നില്ല. Only certain solid exist as liquid crystals. അപ്പോൾ ചില സോളിഡ്സിൽ ചില ക്രിസ്റ്റൽസിൽ മാത്രമാണ് ഈ ഒരു പ്രോപ്പർട്ടി കാണുന്നത്. അതായത് സോളിഡിനും ലിക്വിഡിനും ഇടയിൽ ഒരു സോളിഡ് ലിക്വിഡ് ആയിട്ട് കൺവേർട്ട് ചെയ്യുന്നതിന് ഇടയിൽ ഇൻ ബിറ്റ്വീൻ ദർ ഇസ് എ സ്റ്റേറ്റ്, ദർ ഇസ് എ ടെർബിഡ് സ്റ്റേറ്റ്. ആ ഒരു സ്റ്റേറ്റ് എന്ന് പറഞ്ഞിട്ടുണ്ടെങ്കിൽ ദിസ് ക്രിസ്റ്റൽ by increasing the temperature changes to a liquid crystal. ഈ ലിക്വിഡ് ക്രിസ്റ്റൽ എന്ന് പറയുമ്പോൾ that is a turbid liquid ആണ്. ടെർബിഡ് ലിക്വിഡ്. ഒരു പെർട്ടിക്കുലർ ടെമ്പറേച്ചറിലാണ് ഈ ക്രിസ്റ്റൽ ടെർബിഡ് ലിക്വിഡ് ആയിട്ട് മാറുന്നത്. Then again by increasing the temperature, this turbid liquid or liquid crystal changes into clear liquid. Okay. Now, there are certain solids which when heated undergo two phase transitions, one after the other. That is here, this is the first phase transition and this is the second phase transition. They first fuse sharply yielding a turbid liquid and then again equally sharply at a high temperature yielding a clear liquid. Now, what are the properties of liquid crystals? The first property is the liquid crystals show anisotropy. Anisotropy means they have different physical properties in different directions. This anisotropy is observed particularly in their optical behavior. Thus, they exhibit double diffraction and give difference pattern in polarized light. Actually, the true liquids are isotropic. Isotropy means they have same properties in all direction. The true liquids എന്ന് പറയുന്നത് ശരിക്കും isotropic ആണ്. But the liquid crystals are anisotropic, which exhibit the property of anisotropy. That is, they have different physical properties in different directions. അപ്പോൾ ഇതിനൊരു കാര്യം മനസ്സിലാക്കാം, liquid crystals are different from clear liquids. But this anisotropy properties are similar to crystal property. അതായത് ക്രിസ്റ്റൽസ് എക്സിബിറ്റ് ചെയ്യുന്ന പ്രോപ്പർട്ടിയാണ് ദിസ് അനൈസോട്രോപിക് പ്രോപ്പർട്ടി എന്ന് പറയുന്നത്. Okay. Therefore, in this case, the liquid crystals are somewhat similar to crystals. But at the same time, the liquid crystals are more like liquids in having the properties like mobility, surface tension, and viscosity. For mobility, surface tension, viscosity ഒക്കെ നമ്മൾ കമ്പയർ ചെയ്യുമ്പോൾ liquid crystals are more likely to clear liquids. കൂടുതലും clear liquidsനോടാണ് അതിന് സിമിലാരിറ്റി ഉള്ളത് than crystals. But the properties like optical behavior ഒക്കെ നമ്മൾ ചെക്ക് ചെയ്യുമ്പോൾ that is more similar to crystals. അപ്പോൾ നമുക്ക് എന്ത് പറയാം, liquid crystalsന്റെ properties എന്ന് പറയുമ്പോൾ that is some properties are similar to crystals and some properties are similar to liquids. Okay. Now, the state which is in between the crystal and liquid, that is the liquid crystal, that state is called mesomorphic state. Mesomorphic means intermediate form. Okay. Now, the cholesterol benzoate C6H5, COO, C25H40, H45 was the first solid discovered in 1888 to have a peculiar property. That is, first discover ചെയ്തിട്ടുള്ള liquid crystal ആണ് cholesterol benzoate എന്ന് പറയുന്നത്. It fuses sharply at 145 degrees Celsius to give a turbid liquid. Then further on heating, it changes into a clear liquid at 178 degrees Celsius. That is, the cholesterol benzoate, that is a solid, by increasing the temperature at 145 degrees Celsius, that changes into a turbid liquid. Turbid liquid, that is a liquid crystal. Then again by increasing temperature at 178 degrees Celsius, that turbid liquid changes into liquid, clear liquid. Okay. Therefore, there is a two-phase transitions. The first one is at 145 degrees Celsius and the second one is at 178 degrees Celsius. And these changes are reversed on cooling. That is, these changes, that is, this clear liquid changes to turbid liquid when cooling at 178 degrees Celsius. That is reversible reaction. And the turbid liquid, by cooling again at 145 degrees Celsius, it changes into solid. Okay. Now, the first temperature at which the solid changes into a turbid liquid is known as the transition point. This 145 degree is the first temperature at which the solid changes into the turbid liquid is called the transition point. And now the second temperature at which the turbid liquid changes into the clear liquid is called the melting point. Melting point. Now, the substance showing liquid crystal characters are highly stable and do not decompose on heating. From this, we can conclude that there are evidently four phases or four state of matters in the case of compounds which exhibit liquid crystal properties. That is solid, liquid, gaseous state, and the fourth state is the mesomorphic state. Now the vapor pressure temperature diagram. The phase change involved in the conversion of ordinary solid into liquid gases are solid changes to liquid and liquid changes to vapor, or vapor changes to liquid and liquid changes to solid. But in the case of compounds which showing mesomorphic behavior, there is four state. That is, solid changes to liquid crystal, that is mesomorphic state, and then this liquid changes to vapor. Now, the vapor pressure temperature diagram of the first case, that is 3 state. This is the first state, that is 3 state. That is, solid convert into liquid, liquid then convert into vapor. Here we can see this AO represent the solid vapor exchange, that is sublimation curve, in which solid changes to vapor or vapor to solid. And this OM represents solid to liquid and or liquid to solid. Then this is the vapor pressure curve, that is OB. Here liquid changes to vapor or vapor changes to liquid. Now there is a point O at which the three phases coexist. Okay. Now this is the second diagram. Here mesomorphic behavior. The compound exhibit mesomorphic behavior. That is, there should be one liquid or mesomorphic state or liquid crystal. That is the crystalline solid which changes into a liquid crystal, and then this liquid crystal changes to a true liquid. And this AO represent the solid to vapor or vapor to solid. Here OP represent the liquid crystal to vapor or vapor to liquid crystal, and this BC represent true liquid to vapor, that is vaporization, or vapor to true liquid, that is condensation. Okay, now this O represent at O the solid, vapor and the liquid crystals coexist, and at B the liquid, that is liquid crystal and the true liquid and the vapor coexist. Okay. Classification of liquid crystals. The liquid crystals can be classified into two categories. The first one is smectic and the second one is pneumatic. Smectic means soap-like property and pneumatic means thread-like property. And some other substance which are capable of existing both form, that is smectic form and pneumatic form. Such liquid crystals are called cholesteric liquid crystals. Therefore, we can classify the liquid crystals as first one is smectic, and the second one is pneumatic, and the third one is cholesteric. Now let us discuss one by one. The first one is smectic liquid crystals. What are the properties of smectic liquid crystals? The first property is they have well-defined layers of molecules, and that are able to slide over one another. Its molecules are well-defined layers, and these layers are able to slide over one another. This behavior is similar to sliding effect given by the soap. And we already discussed that the smectic, that word arises from a Latin, that is smectius, which means cleaning, or otherwise it means the presence of soap-like properties. Okay. Now another important point is the smectic liquid crystals do not flow as normal liquids. The smectic liquid crystals do not flow as normal liquids. They have limited its mobility. And the third important point is the smectic liquid crystals are non-Newtonian. This is not non-Newtonian, while that of the true liquids are Newtonian. And another important property is the liquid crystals also give X-ray diffraction pattern like solid crystals, but it is in one direction only. Thus, smectic phases has a complex internal structure. Lastly, they are always uniaxial and not affected by the magnetic field. Now let us conclude the properties. The first property is well-defined layered structure, and these layers can slide over one another. Okay. The second important property is its mobility is limited and do not flow as normal liquids. And the third one is the flow of smectic liquids are non-Newtonian, while that of the true liquids are Newtonian, and they give X-ray diffraction pattern like solid crystals, but it is in one direction only. And the last one is that is not affected by magnetic field. They are always uniaxial. Now, some examples of the compounds yielding smectic phase. The first one is ethyl para-azobenzoate, which shows a transition point at 140 obtained and melting point at 121 degrees Celsius. The second one is ethyl para-azoxycinnamate. Its transition point is 140 degrees Celsius and melting point is 1 to 49 degrees Celsius. The third one is N-octyl para-azoxycinnamate. Its transition state is 94 degrees Celsius and melting point is 175 degrees Celsius. Now the second class is pneumatic liquid crystals. Now the pneumatic type of liquid crystals show near normal behavior of liquids. But smectic in the case that do not flow just like liquids. Okay, but the pneumatic liquids is just like liquids, or they show the near normal flow behavior of liquids. They flow more readily than smectic liquid crystals. Their flow is also Newtonian. Smectic liquid crystals are their flow is non-Newtonian, while the true liquids show a non-Newtonian flow. Here the pneumatic liquid crystals flow is non-Newtonian, and the concept of viscosity is applicable to their flow. And their viscosity, however, is rather low as compared to that of the liquid. This is a pneumatic phase that have liquid-like character and yet being turbid and anisotropic. But pneumatic phase that have more liquid-like character yet that is turbid and anisotropic. They are unlike true liquids. Therefore, the pneumatic liquid crystals are somewhat different from smectic. Smectic that is different, more different from true liquids. But pneumatic is more similar to true liquids. That is, pneumatic phase have a liquid-like character and yet being turbid. That is, pneumatic that is a liquid crystal, therefore it is a turbid and that is anisotropic. But they are more similar to liquid-like properties. This type is therefore regarded as less truly anisotropic than smectic type. Therefore, pneumatic in less truly anisotropic than smectic type. Now, in polarized light, the substances in pneumatic phase appears to have a thread-like structure. Thread-like structures. They are uniaxial like smectic substance. Smectic they are uni-like and not affected by the magnetic field. But in the case of pneumatic, they are affected by strong magnetic field. Okay, smectic that is not affected by the magnetic field, but pneumatic is affected by strong magnetic field. Thus, when viewed in the direction of the line of force of magnetic field, the turbid liquid appears quite clear. Now, some compounds given pneumatic type liquid crystals are para-azoxyanisole, para-azoxyphenatol, para-methoxycinnamic acid, anisaldazine, dibenzalbenzidine. Its transition points and melting points are given. Now the third one is cholesteric liquid crystals. That is, such liquid crystals having some pneumatic and some smectic characters are called cholesteric liquid crystals. That is, some pneumatic properties and some smectic properties, liquid crystal properties. But one more thing is there, only the optically active crystals or solids exhibit this type of liquid crystals. That is, certain optically active compounds show many characteristic pneumatic behavior, but at the same time they show strong color effect in polarized light. That is, certain optically active compounds show many nematic character and many smectic character. This strong color effect in polarized light indicate that they have a layer structure like smectic liquid crystals. But they differ from smectic liquid crystals in having much thicker layers. പക്ഷെ ഇതിലുള്ളൊരു ഡിഫറൻസ് എന്ന് പറയുന്നത് സ്മെക്റ്റിക്കിന്റെ കേസിൽ ഫോം ചെയ്യുന്ന ലെയേഴ്സിനേക്കാളും മച്ച് തിക്കർ ലെയേഴ്സ് ആണ് ഈ കൊളസ്റ്ററിക് ലിക്വിഡ് ക്രിസ്റ്റൽസ് ഫോം ചെയ്യുന്നത്. ദാറ്റ് ഈസ് they differ from smectic liquid crystals in having much thicker layers which are in the order of 500 to 5000 molecules thick. So such liquid crystals having some nematic and some smectic characters are called cholesteric liquid crystals. നമ്മൾ ഓൾറെഡി പറഞ്ഞിട്ടുണ്ട് ഫസ്റ്റ് നോൺ ലിക്വിഡ് ക്രിസ്റ്റൽ എന്ന് പറയുന്നത് കൊളസ്റ്ററിൽ ബെൻസോയേറ്റ് ആയിരുന്നു. That is an example for cholesteric liquid crystal. Its transition point is 145 degrees Celsius and its melting point is 178 degrees Celsius. Molecular arrangements in various states of liquid crystals. The first one is smectic state. This is the smectic state. Here the molecules are arranged in parallel layers. Here we can see the molecules are arranged parallel layers, and the layers are held at regular distance. These layers are held at a regular distance. Okay, parallel ആയിട്ടാണ് അറേഞ്ച് ചെയ്തിട്ടുള്ളത്. ആൻഡ് ഓരോ ലെയേഴ്സിന്റെ ഇടയിലുള്ള ഈ ലെയേഴ്സ് റെഗുലർ ഡിസ്റ്റൻസിലാണ് അറേഞ്ച് ചെയ്തിട്ടുള്ളത്. ബട്ട് വിത്തിൻ ദ ലെയർ, ഇനി നമ്മൾ ആ ലെയറിന്റെ ഉള്ളിലേക്ക് നോക്കുകയാണെങ്കിൽ the molecules within each layer are not regularly spaced. അപ്പം നമ്മൾ ഈ ഒരു ലെയർ നോക്കുക, ഒരു ലെയർ within the layer the molecules are not regularly spaced. Okay, that is the molecules are arranged in nearly parallel layers and the layers are held at a regular distance from one another, but the molecules within each layer are not regularly spaced. The anisotropic properties such as double refraction can thus be readily understood. Now the second one is nematic state. Nematic state. Here the arrangement of molecule is still parallel. അപ്പോൾ ഇതിൽ നോക്കുകയാണെങ്കിലും arrangements of molecules എന്താണ്, parallel ആണ്. That is parallel. Okay, but now there are no layers. അപ്പോൾ ഈ ഒരു കേസിൽ നോക്കുകയാണെങ്കിൽ there is no layers. ഇപ്പോൾ സ്മെക്റ്റിക്കിന്റെ കേസിൽ ഹിയർ ലെയേഴ്സ് കാണാൻ പറ്റും, ബട്ട് നെമാറ്റിക്കിന്റെ കേസിൽ പാരലൽ ആണ്, ബട്ട് there are no layers. Okay, that is still parallel, but there are no layers. The arrangements is irregular and the molecules now have greater freedom of motion. This arrangement would still lead to difference in properties in different directions. That is, it would lead to anisotropic character. Now the third one, that is the normal liquids. Normal liquids. The molecules move completely random. In normal liquids, the molecules move completely at random. This is completely at random. And consequently, there is no scope of double refraction or any anisotropy. The material is now fully isotropic like true liquids. That's all about liquid crystals.